All right, today we will be talking about some two-wire troubleshooting. And we have a very special guest from, I always think of as a Texan, but is in our backyard in Colorado today, Justin Shelby, who runs a company called Perfect Exteriors, who provides coast-to-coast water management solutions for customers around the country. Let me bring your face back up. How you doing, Justin?
I'm doing great, Ben. Good morning, sir.
Good morning. Thank you for making time to join us. I think that you are the perfect guest for what we're going to talk about today. We have worked together in two-wire troubleshooting, and I have actually watched you train different teams of irrigators on this art. And so when I started to build this training subject, yours was the first name on my list of people that I wanted to join me. So thank you for making time to do this with me.
Right on. Happy to be here, man.
All right, so let's jump into the content because there is a ton to get to today. We are, like I said, going to be talking about two-wire troubleshooting. And for those irrigators who have done this know that that is way too big a subject to take on in 30 minutes. So first thing I want to do is kind of isolate what we're actually talking about for you by telling you that I am currently working on the certified H2O two-wire training that will be available at hydropoint.learnupon.com. Our certified training program lives there for free training. Check that out. What we are going to cover today, or when I build that training, it's going to be a training in 4 parts. And the content that we are talking about today is really only pulled from one part of that called the troubleshooting training. And when you look at the troubleshooting training, it's going to be broken into 6 different parts. And what we're talking about today is only one of those 6 parts. So it is not an all-encompassing look at two-wire troubleshooting by any means. As Justin or any irrigation tech who's done this will tell you, it's as much of an art as it is a science. And we are just going to scratch the surface on one of the big topics on troubleshooting your two-wire path today. So we are really only going to talk about troubleshooting issues along the actual two-wire path. So with a two-wire system, as we've covered in previous sessions, instead of having a wire connection or an isolated wire for every valve like you do on a conventional wire system, there is just 2 wires that run through the entirety of the irrigation system. And if any issues should arise along that 2-wire path, it can be high stakes. It can shut down your whole entire system with one bad wire connection. And so while I think troubleshooting is easier on a 2-wire path, it is also very important to keep track of and to know how to do, because again, if one thing goes wrong, there can be a domino effect. Anything to build on that, Justin?
Yeah, I mean, and look, we can expand on that to include what actually is what we call quote unquote the 2-wire path, right? So the 2-wire path would and does always include, and not to be limited to, anything that is also attached to said 2-wire path, right? So decoders, surge arresters, controllers in general. There's a you know, as you branch through all of the different varieties of 2-wire, there's things that can be attached to that, that would be like fusible junctions and some other things, but all of those things combined make the 2-wire path, right? Because the 2-wire path does extend from the 2-wire through the decoder to the actual valve itself or the solenoid, which that also is included in said 2-wire path, because all of those are quote unquote points of failure, right?
Exactly.
They can give us those readings that we're going to talk about here in a little bit, but they can, all of those things can contribute to a negative result in losing not only one maybe particular avenue or said valve or function of the 2-wire, but potentially losing an entire line, right?
Right. So to say that a different way, anytime you have to touch or cut that two-wire path to add anything to it, another branch or a device, or anytime you are making a connection on that two-wire path, that is a potential point of failure. So what we're talking about today is the whole process of testing that two-wire path and anything that's connected to it. All right. So that brings up my stories from the field. These are all different scenarios, and the reason we chose this as the subject of discussion is wiring issues are by far the most common two-wire issue out in the field. So you'll see anytime the wire isn't properly cut, you might expose copper, not even visible to the naked eye. But if you're cutting back the sheathing on a two-wire path and you nick the wire, like is pictured right here where my arrow is, this right here was the point of failure in this two-wire path, because over time there's constant current or constant voltage on that line, and if any part of the copper is exposed, it will wear down and eventually fail. So when you are troubleshooting, far and away the most common thing that you will find, and if Scott Smallin happens to be on the line, he probably recognizes these pictures from when we were in the field together. You'll find things that look like this, where you weren't careful enough just cutting into the two-wire path, or places like this where you weren't careful enough putting the wire connections together and then protecting those connections in the DBRY-6 wire connectors that are provided with every WeatherTrack device that we recommend you use every time, and don't use anything else, just because if you don't protect the wire connections from what is a water-rich environment in those valve boxes, any introduction of water onto this two-wire path will short it out, right?
Yeah, absolutely. I mean, one of the biggest things, especially always to take into consideration when you are running your own business, or you do have folks that are working for you. When you look at that little bitty crack that's in the, that center picture there on that wire, that one little crack, depending on how good you get at the art of troubleshooting two-wire, that could potentially represent a lot. And when I say a lot, 10, 20, 30 hours worth of troubleshooting for a tech to locate that little bitty, we'll just call that a lack of attention to detail when somebody was actually putting something together, right? I don't want to call anybody lazy or say they weren't doing something correctly, but when we put in those junctions together, being very specific, running a non-gloved hand over that wire to make sure that you don't have any nicks, cuts, scratches in that coating, in that sheathing, is really important. And because that one error, that's just, and when we look at it from a business perspective, that one little bitty problem, just the hours alone of troubleshooting that to find out that it was potentially an issue that was self-inflicted, not to mention what that might have caused damage to the landscape, right?
Yeah, absolutely. That nick could shut down 20 stations, right?
Yeah, and that's a huge thing to consider when, as we run businesses as water managers, is our responsibility to take care of those plants and that material. And if we lose that in a lot of situations, that's on our dollar to replace when we go find one of those situations where that wound might have been self-inflicted. So
absolutely, it's not beyond the subject to say that I recommend what I see here is guys that are using wire snips or wire cutters to strip their wires back, and there is a specific tool that makes this a way more safe and repeatable action when you're doing installation. I call it the potato peeler, but there is a tool that makes it easy to strip back those wires without potentially cutting the wire sheathing underneath. All right, so let's keep moving forward. Today, we're going to talk.
Hey Ben, in that in this particular venue, right? One other thing that really needs to be mentioned, because I see it happen all the time. And guys will take those joints apart, and they are, God bless their little heart, but they take and they use that same then grease cap to put the wire nut back into, right? And that is an absolute 100% never, ever, please don't do that situation, because you have basically squeegeed almost all. I mean, the way that is designed, the way 3M designed those things is for that, when that cap goes in there and that skirt that's around the outside of that nut is designed to be flexible. So when you pull on it just a little bit, it's designed to work its way to the outside of the cap, which means it's basically squeegees that entire nut empty again, and it is useless after that.
Yeah, the one use only, absolutely. So if you ever take one of these connections apart, it requires a new DBRY-6 wire nut to regain all of the protection that's built into those. Because when you pull that wire nut out of there, by all means, you're pulling out all of the goo right along with it. So let's see, let's move along here. All right, so today we're going to talk about the process of troubleshooting your 2-wire path. And for this, I'm going to advocate for making a map, using the proper hardware, the proper testing hardware called the milliamp clamp meter, and we will talk about the process of executing the test. So that's kind of where we're going today. First and foremost, the map in any irrigation system is important, but the map in a 2-wire system is critical. And if you don't have a map, make that your first step. Don't troubleshoot a system without a map. And make sure that your customer knows. Like, that's something that is billable, because if you don't have a map, you don't have a logical sequence or an approach to start the troubleshooting process. And it is very systematic. It's scientific in its approach. So understanding the run of the 2-wire path and everything that's connected to it is critical to executing this test. And on that map, we add everything. We add any place that we have touched that 2-wire, right? Any splice box, any valve box, any grounding location, mark all of the sleeves, mark everything, because in addition to putting it on the map, make sure it's in a valve box or at a place where you can access those cuts, because inevitably the places that you cut into that wire are the places that we need to be troubleshooting or testing that wire in the future. And the tool that we'll use for this is called the milliamp leaking current clamp meter. The one that I use is the Armada Pro 95. It's not the only leaking current clamp meter on the market, but it is kind of my standard. It's what all of my customer service team uses. And there's a couple of things to note about the clamp meter that we're talking about. First of all, it's not an electrician clamp meter. The clamp meters that you buy at Home Depot only measure down to the amp level. And in the landscape business, in the 2-wire troubleshooting business, we need milliamp level resolution. So it is more sensitive than just the average clamp meter that you can pull off the shelf. And so you got to make sure that you are using the proper tools to get this done. And the advantage of the clamp meter is that we can test the current going through those wires by clamping around the wire. And again, to Justin's earlier point, avoid taking those connections apart just to test them with a standard voltmeter, because then we got to buy new wire nuts for every one of the connections we take apart. So this makes it possible to test a junction without taking it all apart and getting goo all over your hands and the added expense of a $5 wire nut every time you take one apart. Justin, anything on that?
No, I mean, that's, I am a fan of the Armada. I mean, if you guys, I don't get sponsored by them. We'll just put that out there right now. But I personally am a fan of their of that particular clamp meter. It hasn't ever failed me. So I would definitely agree with Ben on that. That's a good piece of equipment if you are out in the market and you are needing something. Most of all of the supply houses can get Armada stuff.
Absolutely. And we had one great question I have to back up. My buddy Mike Wagner wanted me to point out that making a map is super easy on the weather track now. It's no longer a pad and paper, but using the mobile mapping tool is something that you can definitely walk the site, drop pins, and mark on your weather track map all of the locations, not to be missed. We are also, Mike, to your question, and planning on a future enhancement where you can add lines to that map where we can actually show the run of the 2-wire path rather than just the sequence of valve boxes or testing points along that path. All right. Thank you for that, Michael. All right, so let's talk about what we're testing here. Justin, you want to take this real fast and talk about how we are looking at electricity?
Yeah, so, you know, most of everybody that's on the call probably is a water manager or an irrigator of some form or fashion, whether you're an asset to a business and you're very specific and you work at the business, or you are trying to run a business with techs, or you're a solo guy. Most of us understand water probably a whole lot better than we understand electricity. And so electricity and water have incredible parallels, right? If you consider voltage like water pressure, if you consider amperage as your velocity, right, of how fast we're actually moving water through pipe. And that then has, when you can make that correlation and you understand hydraulics a little bit, one of the easiest things to understand is that electricity, as it moves across a wire, and one of those little sub facts that a lot of people get wrong, electricity does not move through a wire. It moves on the outside of a wire. And something to always consider on that is that's another reason why if sheathing on a wire gets damaged, it doesn't take much to start impeding the flow of the electrical current, because it is traveling along the outside of the wire and not through the middle of the said wire, right? So if you think about that, why electricity, as it moves along, does create friction. And as it creates friction and it goes through something, right? That movement and that resistance is what you then can see, just like when we push water through a pipe, and all of a sudden, as it goes down from the first head to the last head, if they're not all pressure compensating heads and everything hasn't been evened out, the pressure at the first one will be greater than what's at the end, right? And that is due to friction and some things that are happening along that pipe to slow the water down. When we look at electricity and as it goes through something, as it goes through a decoder, or as it goes through even a joint, right, where you have had a wire nut or a splice, you are creating a little bit of resistance. There also, when you look at your charts for your wire resistance, they list very specifically per either 100 or per 1,000 feet, they'll tell you it will have said resistance per that distance that it's actually running. And you're always going to have a little bit of resistance, even on a just straight piece of wire with no joints whatsoever. So if you can think about that just like you would think about water, sometimes that was the light bulb, as I've done a ton of classes and taught, is people think water, 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 and we're trying to talk 100% electricity right here. So,
and that was definitely the light bulb for me, right? Like once I got that, and I got a great trainer. Once I made that connection, it really started to make sense for me.
Yeah. So just remember that, kind of like what we were talking about when we first said, on the wire path, everything is included on the wire path. The decoders, the wire, the controllers, everything that's on that wire path contributes to a certain amount of resistance, which then if you can grasp that concept, it makes the rest of all of this, I don't want to say easy, but it does make it much more palatable.
Right. All right. So we got to get moving on this. We're going to talk. Are you hearing feedback on my mic? I'm hearing my own voice here. So the test that we're going to execute on the 2-wire path involves measuring what's happening on your 2-wire path and comparing it to a calculated value. I don't know what's going on here. Let me try this. Oh. I'll switch to a different microphone. Maybe that'll make a difference. No, I don't know what's going on. Sorry. There we go. That's better. Okay, so back to this. We're going to talk about a test along the 2-wire path that allows us to measure the 2-wire path and see what it's doing and compare that to what the measurement should be, or the expected milliamp value. And the secret to this is being able to calculate what the milliamp draw along your 2-wire path should be. And it's going to be different for every system depending on how many devices we have added onto that system, how many decoders, how many master valves, how many different devices we have will define what the measured value or the calculated value should be. And as a rule of thumb, each device is going to represent about half a milliamp draw on your 2-wire path. So if you have a 96 station controller with 96 station decoders on it of 40, you would naturally measure about 48 milliamps on your system. So it's a very low measurement, right? It's very small that we're looking at. And the details definitely matter in this scenario. So we're going to use that clamp meter all the way around, and just like Justin was talking about, the flow of electricity flows like water, and it flows from the ends of your path back to the controller. So the largest measurements that you're going to have are going to be right there at the controller. So I have in this example, you can see these two paths working together. This guy right here has 6 devices along that path. And so I expect 3 milliamps of draw from this little path. And then I've got 8 devices on this one. And so I've got 4 milliamp draw along this path. When they come together right here, then the draw coming out of this junction box would be 7 milliamps, and it would work its way just like the flow of water back to the controller, where at the controller we'll be able to measure all of the devices together, and we'll be able to see the sum total of all of those individual branches of your 2-wire path. And so again, to start this test, what we want to do is plug in a solenoid on the H2O 2-wire. We'll plug in a solenoid to start the test. So you just put a jumper in here and put a solenoid on one leg of your 2-wire, and that creates a testable signal along that 2-wire path that allows you to really dive in and get the readings that you're looking for. Without this, you're going to be testing a wave, and the wave will bounce all over. It makes it really hard to test. So we put that solenoid in and use our clamp meter starting at the controller. So at the controller, we have 33 milliamps here. And you can see that the 33 at the controller is actually the sum total of the 2 paths that are coming out of it. And with the H2O, we've got as many as 3 paths that can attach to that controller. So the first thing we want to do, if we've got an issue, is isolate which path we're looking at so we can save ourselves just a ton of time. So the expected condition is 33 milliamps. Let's say, for example, we come to that controller and we test 44. This is higher than the anticipated value, right? And really, in real world scenarios, that will be much, much higher. A short drives that reading way up. But for today's conversation, we expect 33 at the controller. We measure 44 at the controller, right? And the first thing I do is isolate which leg that is. So I then test each wire path coming off of the controller, and this guy going off in this direction, I expect 10.5 and I get 10.5. So I don't have to test this branch anymore. It's done. I measure this guy and I expect 22.5 and I get 33.5. And so we know that the issue with the 2-wire path lives along that branch or along that leg of the system. So when you're testing, what I do when I'm first training techs is I have them go valve box by valve box and look for where the current drops. It's a game about chasing the high current. And so you go in every valve box and test and see if that current is still high. And then when it drops, you'll know that you have just passed the issue. Either the issue lives in that valve box or in the last valve box or somewhere in between, but we have just gone beyond the issue on your 2-wire path. And so a great way of doing that, once you've learned out in the field how to do that, you can save a ton of time by just testing halfway. The rule of half: cut the system in half and test. And so if I did that on this path, I get out about halfway and I expect this guy to be 13.5 milliamps because this is 9 and this is 4.5, and I'm still measuring 23. So I know that the path lies ahead, or the issue, I haven't passed the issue yet. It's still ahead of me. So remember, when you are testing, that you are actually testing all 4 wires on the connection. You want to test with your leaking current clamp meter, each wire on the 2-wire path, the red coming in, the black coming in, the red going out, the black going out. Test each one and see what it's doing, because if the issue is with one of these connections, you'll see that drop on the out path, and you'll know you're in the right valve box. You'll know which wire connections you need to start looking at. And so moving on down the path, I go down this branch and I expect 3 milliamps here and I get 13. So I haven't found it yet. I get out here and I find it. All of a sudden my milliamps drop. So I go back 1 valve box and there is my problem, right? That's where I find the issue. I see the significant drop in milliamps and I have isolated the problem. That's when I get to the business of taking apart those gross wire nuts, getting the goo all over my hands, and replacing any wire nuts and finding, like Justin said, testing that wire, taking your glove off and going through and feeling for any nicks along that sheathing that might be exposing the copper. And that's what you're going to see. We're back to this slide, right? These are great evidence of what those issues in the field might look like. Justin, anything to hear on that?
Well, so real world experience is one of those things that's always so tremendously valuable that you can't teach in a classroom a lot of times. And one of the things that, if anybody's ever, I hope, any worked with pipe before, they'll find that they've fixed a mainline break or a lateral line break only to find when they fixed it, they just fixed the weakest link, and now the next weakest link is then going to show itself, right? So meaning you fix that one lateral break or fix that one mainline break, and then all of a sudden it's the cartoon effect. We put our finger in this boat hole, and then all of a sudden water starts shooting out somewhere else. A lot of times on a 2-wire path, that is exactly what will happen. You'll find that major leak that Ben is alluding to when he's sitting there saying, hey, I went down the line and I found this. And then the current goes ahead and it actually draws up and it gives a load on the line, right? Like the controller itself says, okay, I'm going to re-engage, or you're going to relearn that decoder that might be on that line. And then all of a sudden you hit another short. The reason why that happens is because you had a major weak link, and then the other one did not show itself or was not as evident and then the second you fix the one, then the other one jumps up, right?
That's exactly it.
So I would just say that, you know, real world, kind of what Ben was saying, as when you're doing the math and he's showing you a variance of 10 milliamps on that particular example, you might very well see, you might think, okay, I'm supposed to see 10 and you see 11.5. Well, the reality of seeing what you said mathematically versus what real field diagnostics is going to give you, I would say that probably better than 90% chance you're not going to see what you ultimately think you're going to see mathematically just by counting, because you're going to forget some variable that you're going to miss, right? You're going to either miss the fact that you have 10 junction box between point A and point B, or you're going to miss the fact that you have some surge protectors and one of them might not be the world's greatest connection, but it's not throwing a problem yet. Or in, like, if you get into an HOA example and you have 3 miles of wire, well, did you calculate the wire? Because that is going to, at that point, once you have that kind of distance of a run, it is going to start contributing to what you're going to see on that clamp meter.
Absolutely. I'm going to throw you back on Justin. I think what feedback I'm getting is going to be different. Thank you. Awesome point. Thank you for that. All right, so here we go. We are going to finish up. I know I'm running over on time, but I can't emphasize enough the value of using the DBRY-6s. Standard contractor wire nuts are not good enough. Even standard landscape wire nuts are not good enough. They have to be this specific. There are alternatives in the marketplace, don't get me wrong, but just your standard silicone filled wire nuts aren't rated to hold that wire together under the constant voltage that is on the 2-wire path. It'll melt that juice right out of that wire nut, and you might as well be having an electrician wire nut in there. So please, we think it's important enough that we deliver all of our devices with that DBRY-6. And so please use those in every case. And remember, you're just chasing that high current on this test. Look for where the current drops and you will definitely find your issue. A couple of things that were brought up on the chat line. When you make a map, what I do, and this is super nerdy, but when I have a system tight and exactly the way it should, if I'm the installer, I go through and document the baseline readings. I go to every valve box, and in my asset manager, I document what that reading is for that asset in that valve box. And so as soon as I turn on the test, I can walk to any valve box and tell you if it's measuring correctly or not. And that will save you even more time, because then you don't even have to do that cut it in half, cut it in half, cut it in half. You can really just keep chasing it and walk to where you think the issue is, and know at any point that you're testing the system whether the measurement or the measured value matches what we had on the baseline. And so get those wire connections good and make a map. The map is your best friend. The more information you have in that, the better off we're going to be. And that is all the content I have for today. Remember, we are here to help. I'm going to check in next week for with an episode called WeatherTrack Support Resources for Spanish Speakers with another training manager from my friends. My friend Joe is going to join me, and we're going to talk about all of the different ways that we can teach WeatherTrack to Spanish speakers and all of our support resources that we have available for Spanish speakers. So join me for that. Now I'm going to end this. I'm going to put myself on mute. Justin, I finish every episode asking my special guest, what does WeatherTrack save you? Do you have a good answer for that?
Well, so in the grand scheme of things, anytime that I spend money, and I look at, and I'm talking anytime I spend money, I look for value, right? And value to me in HydroPoint comes from a lot of different avenues. One of the biggest is the way the information ultimately goes into the actual system, as far as usability, being able to be programmed on the fly, to be able to be used in a quick adjustment as you are out in the field. A lot of the stuff that I do is to go do new installs, but the stuff when I go and follow up behind some folks and say, hey, let's really look at what the information is that we put into this controller. And the fact of the matter is, in that controller, if you know, for everybody who's dove into the advanced column, and you can really dial that controller in to precipitation rates, you can really dial that controller in. And I would say that when you use that one versus other competitor systems and the available things that you do have to modify, and the speed at which you can modify them to get a accurate water management, what's the best word here? But it's an accurate picture of what the controller should actually be doing as a water management asset to help you truly govern a site.
Yeah, the way I say that is make the information in the program match the information in the field.
That's exactly right. And so many times guys will go through and they'll just say, hey, I got grass and it's sunny and I have sprays. And when I go out there, what I see is MPs on cool season turf. And then I see clay, and we didn't change it to sand. You know, they're all those little nuances. But as far as what does HydroPoint really bring, they bring the easiest, in my opinion, they bring the easiest platform to make the accurate measurement to get water management done correctly.
That's a beautiful answer. Thank you. Oops. Sorry. All right, that's all I've got for this week. Sorry we ran over on time, but special thanks to Justin Shelby, who is an amazing water manager and can definitely, we could go all day on this topic. For those of you who have put questions in the chat box, I will do my best to respond to those via email. I will follow up with you and follow up on any specific questions that I didn't get to. Thank you for participating. Unfortunately, we ran short on time to cover all of those. So we will see you next week. Thanks, everyone.